This is one of the best sections of the year because we're actually going to start taking our linear equations and applying them to where it gets used in the real world. And one of the areas is with best fit lines, or what they call linear regression, which you'll get into eventually, not so much here. We're just going to look at our lines of fit. But a line of fit is a line that appears to fit data. Okay, so we got to collect data first. And this line, this is important, it shows the general direction of the points. All right, so it's got to have the general direction, and has about the same number of points above and below. So if I look at this graph of data, these points right here, I have a red and a blue line. Well, which one you think is a better line of fit? Well, if I look at the red one, there's about the same number of points, above and below. That's not too crazy different. And what about the blue? Kind of the same thing. The blue line, there's about the same number of points above as below. So which one fits it a little bit better? Well, we also have to look at the general direction of the data. So in this case, is it more sloped steeper like the blue, or is it more, elongated like the red? So if you kind of look at these points, you got to look at where the majority are going. Which direction do you feel like they're continuing to go? In this case, this one's pretty tough. Initially I kind of thought the red one, but the more I looked at it, I kind of liked the blue a little bit better. It kind of looked like it's going more that direction. So I really like the blue one in this case. Okay, so it's going to be tough. Sometimes you'll really see it. Sometimes it's going to take some time, and we'll get some practice at this. So let's take a look at another one here that might be a little bit easier to see. So which one of these two would be the best fit? They both have the same number of points on each side of the line. Do you even have to necessarily go through a dot? No, you don't have to go through any of your data. Most of the time you won't. Well, which one has a better general direction? Yeah, line P does for sure, because it looks like our points are going upwards like that. They're not going straight horizontally like that blue line. So that one was a little bit easier to see. Okay, but don't just draw lines through points and just assume it's good. It has to have the same direction. So right here, let's get some practice now. So if I look, I'm going to grab my line here, and let's move it over. Okay. So, let's take a look at get kind of the general direction in this case. So is it more steep this way, or should I flatten it out a little bit? Yeah, maybe a little bit more flat. Okay, that's looking a little bit better. What do you think? Does that look pretty good? I would say so. Maybe I could get even a little more steeper. Or a little more flat. So let's see, how many points I got? 2, 4, 6, 8, 9 below, and 2, 4, 6, 8 above. So that's pretty good. I could maybe even, try to get one of these on the line to be perfect. So maybe something along those lines. So now I got 8 below and 8 above. I went through this exact point. And it looks like I'm going kind of the general direction of the data. That looks pretty good. Okay? Awesome. What about this guy? Yikes, everything is just scattered. Is there really any pattern, As I increase in my x's, what happens to my y's? They're all over the place, right? So can I really fit this line anywhere? This is pretty tough. I'm kind of starting low right away, but I have some, so this is kind of tough. I'd say this is more, just straight even in a way. It's kind of just flattening out like that. It might have somewhat of a verticalness to it. It could even be going down a little bit. I don't even know. This is tough. It's pretty neutral. I'd say this is kind of right in the middle like that. So it's got to have some sort of general direction in order, like this last guy. It had some general direction as it's increasing for us to have a nice line of fit. All right, so let's use an actual example here. So if I took some spaghetti strands and balanced them on some books here and hung a little pail, I could put some pennies inside this cup, and it would just take more spaghetti strands to hold more pennies. And so we did some research, and when I had one spaghetti strand sitting here, I could hold 10 pennies in my little pail. When I had 2 spaghetti strands, I was able to hold 16 pennies. When I had 3 strands, I was able to hold 28, 4, 34. So it's not perfect. Like this went up 6, and it went up 12, then it went up 6, and then 7. So it's not a perfect linear or arithmetic recursion, right, or sequence. So that's why we're going to plot our data and come up with our own line of fit. We're going to write our own equation for this. So the first thing we need to do is bust out our calculators. Okay, so our goal is to write an equation for the line of fit, the line that we, just got some practice putting in. So let's grab our calculators here. All right, so if we're going to graph points on a calculator, what I need to do is we're going to type in some data or some statistics. So if I'm going to type in statistics, what do I need to click on? My stat button, right? So I got statistics, and then right away it's just this edit right off the bat. It's like edit list, but it doesn't show that. So I hit stat and then enter right off the bat, and I got two lists. So this is where my X's are going to go, and this is where my Y's are going to go. I could flip-flop, but then I have to specify stuff, and I just like to put them in order. So number of strands of my X's, number of pennies is my Y's. So I'm going to type them in just like that. So let's go ahead and do that. So 1, 2, 3, 4, 5, 6. Okay, then I'm going to go over to list 2, and they got to match up. So 1 and then 10, right? So 10 and then 16, 28, 41, 46. Okay, so they got to match, right? 110, 216, 328. These are all points. This is like an ordered pair, 434. So when I get them graphed, that's what it really means. It's like an ordered pair. So once I get the list typed in, now I got to graph this scatter plot. These are a bunch of points. So I'm going to go in, right? We typed in statistics. So we want to plot some stats. So the stat plot right here. So second, and then hit that y equals for the stat plot. And we only want to turn one of these on. So I'm just going to make sure they're all off first. So I'm going to go in and turn one on. And does anyone look like a scatter plot out of these 6? Yeah, this guy right here. This is a bunch of dots. That's the one we want. So I'm going to go down, and I'm going to select my one with all my dots, my scatter plot. Then I got to make sure here, yeah, my list 1 were my X's, good. My list 2 were my Y's, good. I'm going to mark it with little squares. That's perfect. Okay, so if I hit graph, boy, nothing showed up. Okay. Is there a nice zoom I could do? Sometimes zoom standard's a good one to always go to right away. But if you notice, we typed in statistics, right? Anytime you type in lists in our statistics, we got a nice zoom function called zoom statistics or zoom stat. So that's a really good one to click. I'm going to click zoom stat. There we go. It's going to fit them perfectly, right? And if I hit trace, it's going to show. This is 110. If I go to my next one, 216, 328. So I can look at all my dots there. All right, so we got them all graphed. That's perfect. Okay. So now it says visualize a line of best fit and choose 2 points to find a slope with. Okay, so I'm not going to necessarily use these points. I might or I may not. But I'm going to visualize a line of fit that's going to go through this right here. So let's think about this. Where would be a nice line of fit? I got to have the general direction, and it's got to be, the same amount above as below. So I'd say something like that maybe. Is that pretty good? I'd say so, right? I got about, 2 or 3 below, about 2 or 3 above. It's got the general direction. Yours might be just a little bit different, okay? But now I want to pick 2 points that are exactly on that line. Well, is one of them, did I go through one of them perfectly? Yeah, I went through this one. Okay, so that one might be a good one to use. What would be another good one to use? Does anybody see another one? Maybe it's kind of nice to use your dashes. If I look like this is 2 for the X. If I went up, what would that be for the Y? Well, I could kind of take a look. I could move. If I click graph again, then I'm allowed to just move wherever I want. So I can move around and put that plus sign like right about there. So at about 2, my Y is, about 18, 18.5. Now let's go with 18. 18 seems like a good number, right? I'll go with 18, okay? So this is about 218. I'm going to grab that point as well. So 218 is one of my points. And this other one right here was, 541. So I'm going to write those points over here. So I got 218 and 541. All right, now we got to find the slope of that. So how do I find the slope again? Yeah, remember it's rise over run. So I got to subtract my y's on top. So I got to take 41 minus 18 over, right? Subtract my y's up top and subtract my x's on bottom. So 5 minus 2. And I end up getting 23 over 3. which is about 7 1/3, but I like to leave my slope as a fraction, so I'm just going to leave it just like 23/3. That's perfect. Let's leave it just like that. Okay, I don't need to do anything else with that. Well, the next thing we want to do is plot the equation y equals mx with slope from steps 2. So I'm going to use this slope. I'm going to plug this in for my m right here. So I'm going to have the equation y equals 23/3x. So I'm going to go into my calculator, and I'm going to graph that guy. So let's see, erase what I just drew up here. So y equals, and let's graph that. Y equals 23. Remember, anytime you have a fraction, put it in parentheses. So 23 divided by 3, and end your parenthesis, times x. Remember that variable button? Let's go back and graph. Oh, that was pretty good. But, my original line of fit, I should have left that on here, was about like that, wasn't it? So what do I need to adjust here to move my line up just a little bit? Oh, I think I heard somebody said it. Remember the y-intercept. I want to adjust this y-intercept and move it up just a little bit. So right now my y-intercept in this guy is technically 0. Okay, but I want to bump it up just a little bit. So if I go back and look, what would be a good estimate of my y-intercept? So if I moved it over there, when x is 0 to get my plus sign, looks like it's at about 5 or 6. I'll use 6. I'm going to use 6 for y, my y-intercept. So that one you might have to mess with just a little bit so you get a nice y-intercept. So I'm going to try 6. And just to mess with it, all I have to do is just go into my y equals and just go all the way over and add a y-intercept. So I'm going to go plus 6. Let's see what that looks like. Oh boy, I went way too high, way too high. So I better go back. Let's switch that. See, so it's really hard to tell by looking on your calculator. So let's maybe go plus, not 62, just 2. I just want 2. Delete, okay. That seems better. I like that much better. Okay, what do you guys think? That looks pretty good? All right, very nice. Okay, so let's take a look. What is the real world meaning of the slope? What does the slope mean, this 23/3 in this place? Well, remember, it's rise over run. So really, rise are my y. So there's really 23 pennies for every, 3 spaghetti strands? So, yeah, if I use my 23/3, I could say there's about 23 pennies for every 3 spaghetti strands. Or if I, simplify that, I could say there's about, 7 1/3 penny per strand. If I'd actually divided them, 23 divided by 3. Oh, sorry, 2/3, my fault. 7 2/3 penny per strand. So either of these would be just fine. Well, what if I wanted to know if we had $5 worth of pennies, how many spaghetti strands it would take to hold that? Well, first of all, my equation was y equals 23/3x plus 2. So where would that $5 go? Well, which ones is the strands and which ones is the pennies? Well, the y were the pennies, right? And the x's were the strands, the spaghetti strands, back from our original. So this has to go in for the y. But do I plug in 5 there? No, this counts how many pennies it is. So $5 is what? 500 pennies. So 500 needs to go in for the y. So I'm going to have 500 equals 23/3x plus 2. And now I have an equation to solve. So I need to go ahead and subtract the 2 from both sides. So I got 498 equals 23/3x. And how do I get rid of that 20? When anytime we have a fraction, you divide by 23/3, right? But we never divide fractions. We multiply by the reciprocal. So I'm going to multiply by 3/23. So that'll cancel, and I'll just have x. So 3/23 times 498. So I'm going to go to my home screen. Every time I want a fraction, I put it in parentheses. So 3/23, and my parentheses times 498. So about 65 spaghetti strands. So we say about 65 strands. And that should make sense. You know, if I look back on my table, you know, 6 strands got me 46 pennies, so for 500 pennies, it should jump up a decent amount. So 65 strands is, you know, a good guess. Well, what if we had 17 strands of spaghetti? How many pennies would that support? Well, grab your equation. Where should I plug that 17 in at? Well, where do the strands go to? The strands are for your x, right? That was our x's, so I just take 23 thirds times 17 plus 2. And I won't finish that out, but your answer should make sense. If I think about it, 17 strands should be, you know, somewhere around like a little over 100 pennies or so. Let's just do one more. Let's find the equation for the line of fit for this guy. Let's try to do it really quickly. Okay, so remember I got to draw my line of best fit. So it might take you a couple times to draw it. So maybe get a straight edge. I can borrow you a straight edge. Let's see. Sometimes it's good to line it up first, and I like about something like that. So how many dots do I got below? 2, 4, 6, 2, 4, 6, 7, or 8. Well, I got too many above. I'm going to redo that. So I need, you know, a little more below here. So let's go like, how's that one? Does that one seem better? I got 2, 4, 6, 7 below, 2, 4, 6, 7, about 7 above. That's pretty good. And I like to sometimes get through a point if I can so I can use it. So I'm going to go just like, there we go. So that looks like a pretty straight line. So now I'll grab 2 points. So I like to grab the y-intercept if I can. That's usually nice. Or I can grab points that go through grid lines, like right here. This one's through a grid line. That's a nice one to use. And then maybe I might grab my y-intercept as well. So I'm not even going to use that point that I went through. I'm going to use those two. So this point is at 0, 7.5, and this guy is at 3, 4. So I got to find the slope first. So remember, subtract your y's on top, subtract your x's on bottom. So I got 7.5 minus 4, right? Subtract your y's on top, and then subtract your x's on bottom. Got to go in the same order. So 0 minus 3, and we end up with 3.5 over negative 3. And let's grab my calculator. So if I go 3.5 divided by negative 3, I get something nasty. I'm going to change that to a fraction right away. Negative 7/6. Let's get nice fractions to use. So m equals negative 7/6. So I like that. Remember, put that right into your slope-intercept form, but we need to find what the y-intercept is going to be. And I got a negative slope. That should make sense, right? My slope is negative. Well, didn't I just find the y-intercept? Yeah, right here. It says 7.5, so plus 7.5. And then I'm done. There's my equation, negative 7/6x plus 7.5. All right, so have some fun with this. We'll actually do a project dealing with some real-world stuff and not too long, so get excited.